This is lesson 5, where we'll learn how to control all the materials and elements, or whatever you want to call them. Now, in the last lesson I introduced you to scale, and I want to show you what kind of a difference scale makes. Now this is everything's default, and this is just changing the scale. There's a lot more detail. But we're not learning about scale, we're learning about iterations. So here's the various iterations. This is 1, the default is 3. And here's iteration 5, adding another 2. Now if you're not sure what iteration is all about, revisit lesson 1. And as you can see by these demos, scale 8 isn't the best to demonstrate on, so I'll be using scale 2 from now on. And I'll start with fuel. Here's a block of fuel burning with the default parameters. Now here I've adjusted the fuel extinguish probability. I've made it a lot more probable that the fuel will extinguish, and this is the effect that it gives. Now for this one I've made it more likely to extinguish, not as much as before, but I've also made it 10 times more flammable, and as you can see it disappears pretty much straight away. Alright, I'm going to demonstrate the iteration stuff on viscous fluid, and here's the default. Now I've minused 4 iterations for this one. Should be less viscous and more fluidy, more watery. And here I've added 4 instead of taking 4 away. Now, simply adding iterations, you'd think that it'll make it more accurate, but it actually doesn't. It has the effect of smoothing out the physics, which I'll demonstrate now by making iterations 30. This is where coefficients come into play. Again, coefficients are in lesson 1. Default coefficient was 0.4. I've increased it by 0.3 in this one. And here I've decreased the coefficient by 0.3, so it'll be a lot more watery. Now remember the iterations are still up. And back to default iterations with the coefficient changed. Again, default iteration, but this time increased coefficient. And here it is with iteration 1, and the coefficients increased in this video and decreased in the next. Now this is no longer very viscous, it's a lot watery, because the iterations are down and the coefficient's down. Now I won't be showing you videos of damping or brittleness or elasticity coefficients, because they're pretty self-explanatory. I'm going to quickly show you how powder explodes. This is default, this is increasing the strength, and the next one decreasing, where you can see it only affects the bottom line. Here I've modified the light probability and the explosive coefficient. And here I've modified all 3 variables to give it a more explosive effect. I'll show you some more variables now. That's up and down coefficients. They apply to gas. And this is default. It actually controls how easily gas goes up or down. Okay, now I've times it by 10 and made it 100, and essentially they're playing tennis, the cooler and the heater. Right, now don't forget from previous lessons that you can actually apply negative values. So I've just simply added minus in front of both 10s for this one. Here I've mixed values. I've basically made it made the gas go down, because down is 1, goes down hard, and up is minus 10, which is actually down. And here the gas formed will be actually protecting the water from the heater. As you can see along the bottom and along the edges, there's heaps of gas, and the water's not making contact with the heater. Thanks for watching, and please subscribe.